Hello my dear students, I welcome you all for SVK tutorials. In this session, I have taken the fourth semester subject called Complex Analysis, Probability and Statistical Method. So in the previous video, we have discussed about sampling theory. I am going to continue that part. The remaining part is called as chi-square distribution, or also called as chi-square test. So this is what I am going to discuss. Already I have given the formula for chi-square. So you know the formula. Chi-square is given by summation of observation minus expected value, the whole square, whole divided by expected value. So using that formula, we are going to solve the problems. Consider a problem. A dice is thrown 264 times and the number appearing on the face named as x follows the following frequency distribution. This is the given distribution table. Calculate the value of chi-square. I need to find just the value of chi-square. So this is the given data. This is what the given distribution. So what we require to find? We require to find chi-square. In chi-square, I need observed value and expected value. So what is observed value? What is expected value? You should know that. The observed value is nothing but the value whatever the given frequency. So that is what the observed value. They have already given. These values are called as observed value. That is 40, 32, 28, 58, 54, 60 are the observed value. Now my aim is to find out expected value. How to find the expected value? Let us see. Start with the solution. Let us assume that the die is unbiased. So then the expected number of frequencies for the numbers called 1, 2, 3, 4, 5, 6 out of 264 times is given by, so 264 divided by 6 is equal to 44. So each faces the numbers face called 1, 2, 3, 4, 5, 6 will appear 44 times out of 264 times. So it will appear 44 times. So this is what called expected value. Next, I have constructed the table for called observed value and expected value. You can go through it. So then I have defined the chi-square formula, that is summation OI minus EI the whole square whole divided by EI. So then I am going to just subtract the observed value and expected value and taking the square of that and divide by expected value. 40 minus 44 the whole square divided by 44. 32 minus 44 the whole square divided by 44. So on continuing like that up to the last value called 60 minus 44 divided whole square divided by 44. So solving this, just solving this by using your calculator, you will get the value of chi-square. That is what called chi-square value called 22. So this is one simple problem I have discussed here. Now let us move on to the important problem. So fit a binomial distribution for the data. This is the distribution table they have given, and also test the goodness of fit given that chi-square at 5%, 0.05 represent 5% level of significance is equal to 7.815 for 3 degree of freedom. As I told you that I need observed value and expected value to find chi-square, right? In the given distribution table, we have observed value. Now I require to find out expected value by using binomial distribution. This is very important point to be noted. The problem should be solved by using binomial distribution. So as you know what is binomial distribution formula, P of x. P of x is given by NCX, P power x, Q power n minus x. So I need P value and Q value. So as they have given frequency distribution table, directly you can't find out the value of P. So use the mean value called mu equal to summation fx divided by summation f. Summation fx divided by summation f. So from this you are going to get the mu value. Summation fx means just multiply f and x. This is, I will name the number of hits as x. That is what I have defined here. Let x denotes the number of hits. Since the data is in the form of a frequency distribution table, so as we are discussing binomial distribution, so we require to find P. To find P, I am using mean mu equal to summation fx divided by summation f. So which is given by product of these two. 0 into 122 is 0 plus 1 into 60 plus 2 into 15 plus 3 into 2 plus 4 into 1. So we got the values here, all divided by sum of f term, sum of frequency. So that is 200. So overall you are going to get 100 by 200, which is equal to 1 by 2. That value will be 0.5. So therefore you got mu equal to 0.5, but is what mu is defined as NP. Now as they have considered, as they have given degree of freedom as 3 here, as in the given question the degree of freedom is 3. As the degree of freedom is defined by the value called n minus 1 is equal to 3 they have given. So I need to find the value of n. So n is nothing but 3 plus 1. So therefore 3n equal to 4. So by substituting n value and mu value, so we are going to get the value of p. I have substituted mu value, n value. So therefore p equal to 0.5 divided by 4, which is equal to 1 by 8, and 1 by 8 in decimal place it will take a 0.125. And once you got the value of p, we can find the value of q. Q is nothing but 1 minus p. So 1 minus 1 by 8 will give 7 by 8. So in decimal place it will be 0.875. So by binomial distribution we have the formula p of x is equal to ncx p power x q power n minus x. So you know what is n, you know what is p, you know what is q, just have substituted those values. So that becomes 4cx 0.125 power x 0.875 whole power 4 minus x. So now I need to find out the expected number of frequencies. It is given by npx. Capital N is nothing but summation f. Summation f is 200. You know what is p of x, just we have defined. Now give x equal to 0, 1, 2, 3, 4. I got these values. I am going to get these values. Here so many things you need to know here. Here you can consider the approximate value called 117. That is what I have considered here. That is what I have considered. This is also approximate value 67. Approximate value of at x equal to 2 is 14. Approximate value at x equal to 3 is 1. When x equal to 4, I have got the value as 0.04. So I have considered the approximate value as 0. So as these two values are less than 10 here, as these two values are less than 10, it is a very important note to be noted here. If the values are less than 10, combine all those values in the frequency distribution table. Combine all those values. Consider all those values as a sum of one term. So it should be less than 10. So then since as it is 1 and 0 are less than 10, I have combined here. That is what I have done. So this is what observed value 2 plus 1. So I got 2 plus 1 as 3 and 1 plus 0 as 1. So similarly I have written the rest of the values, observed value and expected value. And then using the chi-square formula, just I have substituted. So I got the value as 5.0164, which is less than the given value at 5% level. So finally I can give a conclusion that called the fitness is good. The fitness is good. Consider the fitness is good. So here another thing I want to tell you, if you don't go with rounding off the value, instead of rounding off the value, if you write down up to 2 decimal place, the answer will be in terms of just 4.9, I think. 4 point, you are going to get the answer in terms of 4.9, which is also less than the given value at 5% level. So nothing to worry here. Okay, and one more thing, observed value should be equal to the expected value. Here observed value is 200. If you consider the rounding of the value, it is 199. So as it is nearest to 200, so I am not disturbed with these two values. If it is more difference, if you find, then what to do, I will tell you in the next problem. Okay, point to be noted here. Moving on to next problem, fit a Poisson distribution to the following data and test for its goodness of fit at level of significance 5%. So this is the given distribution table. So definitely you can name this as observed value, whatever the given f, you can name this. So as you know, Poisson distribution is defined by what? P of x is equal to e power minus mu into mu power x divided by x factorial. This is what the Poisson distribution, e power minus mu into mu power x divided by x factorial. So I need to find out mu value. Mu is what? Summation fx divided by summation f. So considering those two values, I got the value of mu as 0.904. Now I need to find out the expected value. So I am going to find out the theoretical frequencies given by the formula called npx. So what is n here? N is 1000. So summation f is equal to 1000 here. So 1000 times of p of x. 1000 times of p of x. What you are going to get? So similarly, just give x equal to 0, 1, 2, 3, 4. So you got these values here. And the total of this value is 997.4. Here I got the difference of 3 values. That's why. So what is the difference value here? You should see that difference value. Just subtract by 1000 minus. You are going to subtract with 1000. You are going to subtract 997.4. So what you are going to get? What is the value you are going to get? You are going to get 2.6. So I am going to just divide these two, this value by 2. So I am going to get the value as 1.3. So adding this value with, so if I add 1.3 to the end intervals, I am going to get the value as 406.2, and here I will get the value as 12.6. Now if you consider sum of this, you are going to get the expected value is equal to the observed value. So now using these values in chi-square formula, I am going to get 5.748. 5.748. So as there are two constraints, so that the number of degree of freedom called nu is nothing but 5 minus 2. As we find out two constraint, we put a two constraint for two values. So that's why I am subtracting that number of values by 2. I am going to get a degree of freedom as 3. So for nu equal to 3, at 5% level, the degree of freedom is given by the value 7.82. You should look at the distribution table, chi-square distribution table. By looking at the distribution table, we can come to know the 5% level is 7.82. So as this value is now as you know that chi-square is given by what? 5.748, which is less than 7.82. Therefore, I have defined that chi-square is less than chi-square at 5% level. Hence, the fitness is considered as good. So, my dear students, here I can conclude the chi-square test saying that concentrate on binomial distribution and Poisson distribution, and also sometime there is an chances of asking normal distribution. Concentrate more problems on binomial distribution and Poisson distribution. So whatever the problem is given, whatever I have explained, in the same manner you should solve the problems. Okay. I thank you all for listening to my lecture. If you like this video, kindly do subscribe to my channel.